Probably for me, I usually write it y equals f of x will work. Y probably is a good way to say it because that's the way we remember lines. Y equals mx plus b. F of x equals mx plus b. So for a absolute value, it's a absolute value of x minus h, close the absolute value, plus k. Your vertex is going to be hk. And I'm going to put a positive there. And actually, you can put a positive in front of your k if you want to, too, because I'm going to show you what I'm talking about. Let me go pull my examples. Do you remember with the number that was on the outside? That's your k. Do you remember that if it was a positive 2, then your vertex had a positive 2 for the y? So the number on the outside affects the y. When it was negative 3, then the vertex had a y of negative 3. And when there was nothing added on outside, y was 0. There was no movement on it. So your k is going to determine what your y value is of your vertex, and it will be the exact same number. Remember, if it was positive 2, we went up 2. If it was negative 1, we went down 1. Now the h here is a minus h, and this one is a plus h. Now that just simply means they're the opposites. If this is plus, this is going to be minus. Well, I think we did one of each right here. Positive 2 affects the x, and it made the x negative 2. It made its opposite. See, when this was positive 2, the x of the vertex was negative 2. When this was negative 1, the x of the vertex was positive 1. So that just simply means they will be opposites. And then the other factor is a, but it's going to give you two things. The first thing is the idea if a is positive, it's going to open up, which was every one of ours, including the parent, except number 7. And so then if a is negative, it's going to open down. Now, because we're just talking about the number, the positive negative did not affect how big it was. Remember how wide or narrow it was? So we're going to say absolute value of a equal to 1 is what I call standard size. Same as parent. And then if absolute value of a is greater than 1, now that was the first one we did, that was number 5. Remember, it made it narrower or thinner, I guess is the way we wrote it, thinner than standard, the parent. Now you remember, the parent is who you always go back to. And then, now I put 0 on this because even the absolute, a could fall into that negative on this one. I'm not sure. So I've always put it like this. If a is between 0 and 1, because I'm just interested in I think that probably doesn't have to be there, but I just know that when you start talking about being less than 1, it could possibly get into some other things. What we're talking about here is it's going to be a fraction. It's between 0 and 1 size-wise. 1/2, 2/3, 1/5, 3/4, that type. Then it's going to be wider than standard. Do f of x is equal to 2, absolute value of x minus 3. Okay, here's the first thing you want to do is tell me what the vertex is going to be. This, remember, affected the graph left-right, your x, and what did we do to it? The opposite. So that's going to be positive 3. And if you want to draw an arrow and say opposite. And what's nice about this, when you graph anything, trigonometric, whatever, that has any kind of grouping symbol, we're going to do the quadratics, the squares, the cubics, whatever, it moves it left or right. That's what's nice about these transformations when you have something grouped like this. And then what's on the outside affects the y. Well, in this case, there's nothing there, so what's the y? So it was 0. That's the same as a plus 0. Now, let's talk about that 2, what it's going to do for us. To do that, let's first go ahead and draw our x and y axis. And we're only doing 4, so you should have plenty of room for these. Well, how's it going to open? Sometimes I ask that. I don't necessarily ask it if you're graphing it because I can see what you're going to do to it, but sometimes I do if you're not, like on the midterm or something. What, look at right here, what affects it, whether opening up or down? What's the sign of that number? A positive, and if A is positive, it's going to open up. You need 1 point to the left and 1 point to the right to get the shape of your V. So to do that, what they say is get your vertex, and then they'll say do a number to the left, make a t-table, and do +2 and +4. But then I saw this trick that relates it to slope, and so we're going to use the 2. A equals 2. The absolute value of A is 2. We'll do it like that. Now, do you remember, we even did one that way, but how do we graph it? The one we did in number 5 had a 2 in it. We're going to treat it like slope. Do you remember slope is rise over run? I don't like to write this because it's really not lines, but we're going to put rise over run. Because when this number is a +2, we're going to go up 2, and then we're going to go over 1, and that means to the right, to get your point to the right of the vertex, am I on screen? And left. Because you need one on the, and there's symmetry to it. So watch what we're going to do. From our vertex, we're going to go up 2, and we need 1 over here, and that would be it if it was a line, but we need the symmetrical one over here, so we just go 1 to the right and 1 to the left. Now, where it's different is when this is a fraction. You don't treat it like that. So I have to be careful. It's similar to rise over run, but it's a little bit different. Now, here's the weird thing. It will work, what I'll show you will work with absolute value, but it doesn't work with quadratics. So you want a shortcut that will work for all of them. And there's your V with no t-table, no graphing calculator. The run has to be 1. Always 1. Okay. Number 9. And yes, it will work with these, but not everything. Because you're looking for symmetry all the way up, and it just doesn't work when you start squaring numbers. Let's do 4. Absolute value of x plus 2. Close your absolute value, minus 3. Okay, let's do the vertex. Let's do, you want to go ahead and tell me how it opens? Okay, positive number here, opens up. Are you okay? Everybody good? And then we'll talk about our stretch in just a minute. That's what I call that. I call that the stretch. So what's the vertex? -2, -3. X. Do you know why it opens up? Because that's a +4, positive A there. And then we have a stretch of 4. So to graph the stretch, let's just write that. Stretch 4. Now normally I don't even ask for that because I'm going to see it in your graph, but you're going to go up 4. And then I just say over 1. And when I mean by that over 1, you're going to go left, right 1, and you're going to go left 1. That gets the symmetry of the t-table, ever how you want to do it. So over 1 means both ways. Okay, plot your vertex first. -2. And now not having to state everything, and I don't know that I even ask you to state anything on your classwork because I'm going to be looking at your graph. The stretch is 4. So we're going to go up from here, up 4. 1, 2, 3, 4. 1 to the right, 1 to the left. The bigger the number, the skinnier it gets. And I think that shouldn't surprise you. When it was 1, we haven't done a 1 yet, which is the parent. But it's just going to be up 1 over 1. See how much faster they are? F of x, and like I said, use your notes. F of x equals, now it's just probably going to say absolute value of x plus 5. But there's an understood 1 right there. Remember, the parent has a 1 in front of it. So, what's the vertex? 0. So our y here is a 5, so the vertex is 0, 5. It's going to open down. Do you know why? And you can just say down if you want to there. And then the stretch is 1. And usually you're not going to write all that stuff in your classwork. Remember, adding 5 on the outside moved it up 5. Now, if this was just a 1, we would go up 1 over 1 both ways. But because it's negative, all it does is it's flipping it over, and actually it's flipping it over this line here. So we're going to go over 1, down 1, over 1, down 1. So number 11, f of x equals, and the last one we're going to do it all. Negative 2/3 absolute value of x minus 1, close your absolute value, plus 2. Now, I'm going to put a star by the a here. Will be opposite of this one will be a positive 1, and I'll put it there just to remind you. And then it's going to be positive 2. Opposite the same. How does it open? Down. And the a is 2/3, so it has a stretch of 2/3. Now, I want you to draw something where it comes from. Now, you're going to go up 2/3, and you're going to go over 1. Now, I know up to over 3 will work on this one because they're like lines. But we're fixing to start graphing very quickly when we get back after break. We're going to start graphing these curves that put a squared here, and when you square that x, it's not a line and it's not slope per se. So you can't treat it. Your denominator is 1. You're always going to go over 1. And I tell people it's doing the t-table. It's like when you graph the vertex. Let me show you. So it's taking a shortcut to the t-table. That's why I always say you're going to do 1. What was the vertex? 1, 2. So I'm going to go down 2/3. Oh, I said up 2/3. I didn't put down because it's negative. Sorry. That's because of the negative. So we're going to go down 2/3, and I'm just going to put a little dot there, just eyeball it, a little more, a little more than half, and then over 1 and over 1. See, because if you were doing it on a t-table, you would have put in 0, and you would have put in 2. Remember, it's going to be wider. Now, it's not, because 2/3 is very close to 1, it's not going to look a whole lot wider than the parent. And there's your graph.